Section 4.7 starts us with the law of sines. So some of you might have seen this before, but we're going to do a quick derivation and then just one example of how you use it, because it is pretty straightforward. So law of sines is one of the ways that we can solve oblique triangles, which just mean we have non-right triangles. So I'm going to put one in here, and we're going to derive the law of sines. So I have here a non-right triangle, and I drew in one of the heights, and I'm going to label the sides. Now, for this section and for pretty much the entire year, if we're given angles, we label the sides with the lowercase letter across from the angle. So I just put an arrow there. Since angle A is the bottom left, little a will be the side length across from it. And same thing for B. We've got B and B across from each other, and angle C and side C across from each other. So that's just some notation that we'll be using throughout the year. So the first thing we'll do is, since we drew in that height, we can actually set up for this height two equations. So I have up top, let's go back a little bit, sine of A over, pause there. Sine A equals the height over C, opposite over hypotenuse, if we cut the triangle in half. And then side C equals height over A. So I'm going to solve both of these for the height. And then we can set them equal, since they're both equal to the height, and finish solving through. So I'm going to write out the whole law of sines here. And you guys can check out my steps. We could do this again. Remember, there's 3 heights of our triangle. So we could have drawn a height from side C, for example, over here, and then used angle B and angle A. I know my angle isn't a right angle. To derive the law of sines, but we will have to use it. You don't need to know how to derive it, but it's always a good thing. We can use law of sines whenever we have 3 measures in a triangle, including an angle and its opposite side. So we'll see in the example. I don't think there's much more to say about that, but remember, to solve a triangle means to find all its sides and measures. We do have to watch out for the special case, you guys might remember from geometry, that does not prove congruency, which is side-side angle. We'll be covering that in a future lesson. Today we'll just stick to our normal law of sines cases. All right, so we're going to do a practice example here. I would pause for a second and maybe write it down, or just watch through and make sure you can follow. So usually they'll just give us some measures for a triangle, and we'll draw our triangle out. So I'm going to put in the measures they gave us. They gave us 2 angles and side L, which I drew across from angle L. I try to make my pictures kind of to scale. Like if it's an obtuse angle, I'd try to draw it obtuse. Doesn't really matter, but sometimes it's helpful to see if your answers seem right. So we can find this first angle by subtracting the given angles from 180. I got 39. And now I can set up a law of sines ratio. So we're starting with sine of 29 over 22. I highlighted that guy. 29 and 22 are across from each other. And then I'll start with angle M over here. And the side across from him would be side M. So that's our missing right now. Once I have my ratio set up, I can just cross multiply. So I'm going to put M on one side, everything else on the other. And then we're going to throw it in our calculator, making sure that we are using degree mode. And I got 42.074 as that last, or as that side M there. I've got the M underneath. Let's get rid of it first. Throw side M where he belongs. All right, so now, remember, this is not a right triangle, so I can't use Pythagorean theorem to find my last side. So I'm going to set up one more law of sines ratio using, I like to use the originals given, so 29 and 22, so I don't have any decimals to deal with in case I made any mistakes. I'm going to get n on one side, throw everything else on the other, and throw that guy in my calculator, and I got 28.558 for my last side. So I have successfully solved the triangle. I found the 2 missing sides and the missing angle, and we're all set with our law of sines.